Good morning. We're going to start. So my name is Valérie Faudon. I'm the Executive Director for the French Nuclear Society. We are a scientific association gathering 4,000 engineers and scientists working in nuclear in France. Today the title of our conference is Nuclear Energy Part of a Solution in the Fight Against Climate Change? And it's part of the activities we are organizing as part of our initiative we've launched with about 148 other nuclear associations around the world called Nuclear for Climate. So one thing we think has been missing in the question of nuclear as part of a solution to fight climate change has been civil society-based advocacy. So we are very happy today to welcome 5 advocates. So let me introduce them. The way we will run the session is that each one of them will do a 5-minute introduction, and then we'll open for questions, because the essence of the meeting today is actually to run a debate. So let me first introduce François-Marie Bréon. François-Marie is French. He's a climatologist. He's a lead author of the IPCC Fifth Report, Group 1. He's currently the Deputy Director for LSCE, which is the Laboratoire des Sciences du Climat et de l'Environnement in Saclay, in France. Next to me, Kirsty Gogan is an Irish citizen, and she's the director for an NGO called Energy for Humanity, an environmental NGO. Rauli is a Finnish citizen, and he's a writer of a book that I think will be available for you to take with you after the conference if you wish to, called Climate Gamble. Ben Hard. Ben is an Australian citizen and is a director from a think tank called Think Climate Consulting. And then Stephen Tidell, next to François-Marie, is a British citizen, and Stephen is a director of a pro-nuclear think tank called the Weinberg Next Nuclear Foundation. So I will first give the floor to François-Marie for a 5-minute introduction. Thank you.
Thank you. Good morning, everyone. So as Valérie just said, I'm indeed a researcher. I've been working on climate and climate change for more than 20 years now. And I participate in the drafting of the last IPCC report. And because of my work of the past 20 years, I'm really convinced that climate change is a serious threat to human people. And one reason why I think it is a threat is because of the analysis of past climates. Let me give an example. Just 20,000 years ago, which is not that long. I mean, 20,000 years ago, they were human beings like you and me, even if we didn't have a microphone on iPhones. But people were painting in caves. And so 20,000 years ago, it was the last glacial maximum. Last glacial maximum meant that there was 3 kilometers of ice over what is now Canada or what is now Northern Europe. The vegetation distribution was fully different than what it is today, and the sea level was about 120 meters lower than what it is today. So the climate was really fully different than what it is today. And the Earth's mean temperature was about 5 degrees lower than what it is today. And the prospect of the climate change, the mean temperature rise by the end of this century is about the same order of magnitude. And the climate change going from the last glacial maximum to the climate that looked like the one we have now took about 10,000 years. But now we are looking for the same kind of climate change, but not over 10,000 years, but over 100 years. And therefore, it's pretty obvious to me that most ecosystems won't have the time to adapt to this climate change. And then it will be extremely painful And in particular, the prospect of the sea level rise will be extremely painful, but there are many other impacts of climate change that will be dangerous. And we know why the climate changed from the last glacial maximum to what it is now. It's mostly because of the orbit of the sun, of the Earth around the sun. But we know also that the first impact was reinforced by the change of carbon dioxide in the atmosphere. And actually, if we look at the ice core from Antarctica and Greenland, we know that in the past 1 million years, the carbon concentration in the atmosphere varied between 170 and 270 ppm. And now we are at a level of 400 ppm. So therefore, we are fully away of the natural range of carbon dioxide in the atmosphere. And the concentration is still increasing at a rate of 2 ppm per year. And we know why that is. It's because of the human activity. We are emitting about 40 billion tons of carbon dioxide that are emitted every year. And therefore, if we want to stabilize climate change, there is really a need to go to almost zero emission by the end of the century, and we need to do that really fast. I mean, we cannot wait for the middle of the century and then start to decrease. I mean, it would be really too late within about 10 years. And therefore, there is really a strong need to get out of fossil fuel. And I know that there are many organizations that say that we need to go out of the fossil fuel and we need also to get out of the nuclear industry. But in my opinion, the impact on the environment of fossil fuels is much, much larger than the impact of the nuclear production of energy. And that, I guess, would be the topic of discussion today. But in my opinion, because the impact on the environment is much lower, then we need to get out of fossil much sooner than we can get out of nuclear energy. So maybe I would agree that a world without nuclear energy is maybe better than a world with nuclear energy. But I'm fully convinced that the priority should be to get out of the fossil fuel energy. And then maybe once this is realized, we can think about getting out of the nuclear energy. And that will conclude my talk. Thank you.
Thank you very much, François-Marie. I'd like to leave the floor to Kirsti. So can you tell us...
Thanks, Valerie. I think François-Marie has just really set out the nature of our challenge and the scale of the challenge and the urgency of the timescales that we're facing. So my name's Kirsti Gogan. I'm the executive director of a new environmental NGO. We're independent, and we're focused really on two of the great challenges that we're facing in this century. First of all, of course, the need to dramatically reduce our carbon emissions very rapidly. But secondly, how to lift billions of people out of poverty to enjoy just a fraction of the quality of life that we take for granted. And these two challenges have one thing in common, and that's the energy that we use to power our world. So the question is, could 9 billion people live like we do, travel like we do, eat like we do, whilst also tackling climate change? What changes in our lifestyles are actually required? What combination of supply and demand measures are needed? And, so the bad news is that there isn't a silver bullet here for the transition that we're trying to achieve. But the good news is that we do have a lot of tools and ingenuity at our disposal. So I think fundamentally I am optimistic that we can meet this challenge. And in fact, 6 countries in the world already have. They have already achieved the goal of decarbonizing their electricity generation, which is, which should be our first priority if we then need to go on and electrify heat and transport. Now, these 6 countries, this is a fun quiz question, isn't it? So we have Iceland with geothermal, we have Norway with hydro, and then we have 4 countries, including France, who've achieved that with a combination of nuclear and renewables. So that's Brazil, Sweden, France, and Switzerland, so that you've got the answers to the quiz question. So that's really important. But that combination of nuclear and renewables is really, really important because, as we're seeing in Germany, trying to replace one form of low-carbon technology with another is really difficult because if with intermittent sources of energy, like wind and solar, for example, you're not only facing gaps in supply over, say, hours or days when the wind's not blowing or the sun's not shining, but actually those gaps can be seasonal. So right now we have no prospect of a storage solution that can fill that gap over months when electricity is needed and we need to keep the lights on. And so what happens is that in Germany we're turning to coal, but ideally what we would have is a low carbon source of base load power, and by base load I mean always on. So last week here at COP21, 4 of the world's most famous and renowned climate scientists, including Dr. James Hansen, the godfather of climate change, he first raised the alarm about climate change 20 years ago. So these 4 climate scientists, they issued a call to action to rise above prejudice and ideology for a more rational climate strategy. You know, it reminded me of that cartoon where over a number of frames you see the scientist in the white coat saying, this is a very serious problem, we really need to solve this problem, we urgently need to address this issue. And over a number of years, the scientist comes back and continues to raise the alarm, and eventually, in the last frame of the cartoon, he's tapping the microphone saying, is this thing on? And I felt like, so these scientists came and they tapped the microphone. It was the first time that Dr. James Hansen had come to a COP, and the first time, in fact, that 3 of the 4 had ever come to these climate talks, because they said, well, this is for the politicians, you know, not the scientists, or maybe that's part of the problem. So they called for us to put our differences to one side and to include nuclear in the mix, because we need to throw everything that we've got at this problem. Now, nuclear energy, it is controversial, and I understand that. I haven't always been pro-nuclear. I'm a lifelong environmentalist, and by default, I was anti-nuclear. And I changed my mind. I read studies by the World Health Organization and the United Nations, and I looked at the maths, and I began to understand that we wouldn't be able to scale up renewables fast enough or to the scale that's needed to replace fossil fuels. So crunching the numbers, it became pretty obvious that we were going to need nuclear in the mix as well. And along the way, I've discovered that a lot of things that I thought about nuclear were wrong, you know, not least in terms of safety and the volume of waste and the risks that poses, especially when you compare it to coal. You know, normal operations of coal kills more people in one day than have ever been killed in all of the nuclear accidents combined. So, as Dr. Ken Caldeira said last week, we need to stop using the sky as a waste dump, because actually that's the waste stream that I'm really concerned about, which is coming from coal. And the best way to do that, to stop using the sky as a waste dump that's been proven to work in the real world, is through a combined strategy employing all of the major low-carbon energy options, and prevent the worst effects of climate change in the time that we have left. Just one final thing, it is tempting to think that we could stop carbon emissions by saving energy, but it would really be a mistake to overestimate the role that energy efficiency can play in meeting our carbon reduction targets, because electricity consumption is forecast globally to grow, and we hope that it will. Now, Ben's going to speak more about this, but just to finish, so my organisation is called Energy for Humanity, because not only do we need to solve climate change, but we really do need to find ways for people to achieve the quality of life that we take for granted. Today, half of the world's population lack access to electricity, but they quite rightly aspire to the rich lives that we enjoy, with not just for household use, but modern energy services, water sanitation, hospitals, street lights, cash machines. So access to energy should grow, Today, nearly 2 billion people cook over open fires fueled by wood and dung or charcoal, and the health consequences of this are severe. Indoor air pollution causes 2 million premature deaths per year and half of all pneumonia cases of children under the age of 5. So the question is, that I'll leave you with, is could 9 billion people live how we do, travel how we do, eat what we do? And I believe that we can tackle climate change and create a safer, more secure world, less vulnerable to the effects of catastrophic climate change. But to do this, we need to throw everything that we have at this problem, including nuclear. Thank you.
Okay, thank you very much, Kirsty. I'd like to give the floor to Ben Hurd from...
Think Climate Consulting.
Have some slides.
And the University of Adelaide. I have a few slides which I'll lean on just to make a few important points. Kirsty mentioned doing the numbers, and part of my thesis research has required me to try to do the numbers on the prospects of the counter-argument, the prospects of running a world on 100% renewable energy sources. And as Kirsty said, we have almost no real-world evidence of that. Some small, what you would call outlier nations with very specific resources that enable them to achieve that outcome. Just about all the rest of the evidence lies in literature. It's paper evidence. And it's worthwhile, therefore, to have a look at that literature as a body to understand what it tells us about whether this is possible, because the fact is we don't know, and were it possible, what the implications of that pathway would be. Because while there are many energy sources that reside under what is effectively a brand, which is a word called renewables, they are very, very different. There is almost nothing in common between a solar system on the roof of a house in Adelaide, where I live, and a large hydroelectric dam across a river in a tropical forest. And yet they reside under the same brand. The fact is, you might be able to talk about a 100% renewable energy system. Just because it's renewable doesn't mean it's sustainable. Just because it's renewable doesn't mean it's low impact. Just because it's renewable doesn't mean it's desirable. Just because it's renewable doesn't mean there won't be serious concerns and objections from many, many stakeholders that will make that pathway very, very hard indeed. There's a couple of key points that I want to mention from the research that we have undertaken. The first relates to those energy demand assumptions. Valerie, if you could just click down a slide for me to a particular chart. So many of the studies in the literature for addressing 100% renewable energy are predicated on first dramatically reducing the primary energy needs. What you see on the chart in front of you is 28 energy demand scenarios from mainstream organisations, predominantly the IPCC with the SRES scenarios and the RCP scenarios, the Climate Change Science Project from the United States, which includes many strong mitigation scenarios, and the World Energy Technology Association from Europe. The curling black line at the beginning of the chart shows our actual energy demand pathway, and the dotted black line heading in a straight line up the chart is the median of those non-ENGO mainstream scenarios. There are then two more lines. The green line shows the energy demand trajectory proposed by the Greenpeace 100% renewables pathway, and the blue line, the WWF 100% renewables pathway. Now, probably every action, every lever that's proposing to be pulled to reach that outcome is something which in isolation I would probably agree with and support. However, in order to reach that outcome, those levers need to be pulled so hard, and they need to be pulled all together, and they become interdependent, that you end up with a situation which, on the balance of evidence from all the other scenario work, is probably not the world we're going to have. And if we start designing a supply system of renewable energy to meet a world that's very unlikely to materialise, then we're shooting ourselves in the foot right at the start. This is an unrealistic, fragile pathway that is vulnerable to failure. It's not respecting the lessons of history about how fast we can change and upend our energy supply systems, and it has extremely troubling implications for just what is assumed about the future energy demand in a lot of countries that right now are very, very poor. We can't design a supply system for a world that probably won't exist. Any responsible pathway would be looking to the middle of that band, would be looking to where all of those studies are clustering and trying to envisage solutions that would meet a world that looks like that. One further troubling pathway I find on the sustainability perspective, and Valerie, if I could just have one more slide, please. There's maximal exploitation of what I would call high impact renewable energy sources like hydroelectricity and biomass. Now, right now we have a situation where Indigenous tribes are banding together to object to the production of hydroelectricity in their regions because it's not low impact, it's high impact. And if you can see the distance, Valerie, if you just move down to the final slide, this facility is thousands and thousands of kilometres away from where the bulk of the Brazilian population lives. This is outsourcing our responsibility to provide our energy to someone else's land, to our wild spaces, to our frontier rainforest. I find that unethical. Down at the bottom, you may see a very small red line running from Buenos Aires to a nuclear power station just 100 kilometres away. It takes up a tiny amount of land. It's in land that's already developed, already farmland, already has been turned over to modern human life. It's not interfering with our wild spaces. I think it's time that those of us that are living in our cities with our modern lives take responsibility for the production of our energy. If we follow this 100% renewables pathway, it will effectively call on us to create a grand machine out of nature in order to leverage all of these ambient energy resources, the biomass, the hydro, the wind and the solar, to provide what the minor miracle we see around us now, which is this reliable electricity supply. It's not a pathway I support. It's a pathway I consider that is fragile, vulnerable to failure, and doesn't give us the certainty and security that we should be following at this critical juncture, a pathway that we know can work. And we have evidence of what we know can work, which is an intelligent, rational, mixed portfolio of nuclear and renewable energy sources based upon the varying advantages and disadvantages that each nation will have in all of those energy sources. That pathway works. It is folly to reject it at this point in time. I will look forward to taking many more questions. Thank you for your attention.
Thank you very much, Will. I will now leave the floor to Rolly. I think you also have a few slides to share. I'll try to find them.
Hello. It's a pleasure to be here. Can I have my slides? I'm going to continue where Ben left. We wrote this Climate Gamble book, and during the years of research, we studied many reasons that why opposing any tools in the fight against climate change is going to be a reckless gamble with the whole climate. Can I have the next slide? So here's the first one. I'm going to go through rather fast. This is a picture from 2011 IPCC study on renewable energies. They estimated 164 different scenarios of renewable energy futures. And the average and the median value they had is that we might be able to produce about 1/3 of the energy that we currently use with renewables by 2050. And as we all know, a lot of the, especially wind and solar capacity that's currently being built around the world is built because of political subsidies and tariffs. So there's going to be these bottlenecks coming up on the political side as well. As they are intermittent, their costs will escalate with time, and actually way before than enough has been built, unless we solve the elusive problem of energy storage in a very affordable way. The next slide, please. Oh, there was the. Can I, put the bullet points there? I have this, my own presentation here. So the same goes for nuclear, but mainly for a bit different reasons. We all know that there's a lot of bottlenecks, both political, social. The people do not like the idea of more nuclear. Obviously, if we are to succeed in the climate fight, that has to change, but that will take time. We have bottlenecks in the lack of skilled labor, regulatory stiffnesses, inexperience. We have had a long time of no new capacity being built, especially in the Western nations. And as we learned in Finland with Olkiluoto, there is a little bit of rushed also in the regulatory authorities. And there is also this question that has not yet been answered, that how can we replace liquid fuels with electricity economically? Next slide, please. And yes, put that. Oh, too many. So there's this price on carbon that everybody would like to have, I assume. And but the problem with that is that we cannot put as high price on carbon instantly that we would need, because right now our whole society is powered basically by fossil fuels. And there is a reason for that. They are great. They're very dense, cheap energy compared to many others. But they're also cheap because they have externalized a lot of their costs, like particulate pollution and, of course, greenhouse gases. And even building a new infrastructure of solar panels, wind turbines, nuclear power plants is going to happen with fossil fuels, mainly with oil and natural gas. So we cannot actually ban carbon or ban coal, because the whole system operates on that. You cannot ban breeding, or maybe for 1 minute you can, but it's going to be politically impossible to do it or longer term. Next slide, please. So then there is the option of using less energy. I am all for that, but we also need to look at that in a realistic manner. That there's billions of people in the world who have very much reason to hope to use actually much more energy than they are now using. Also, we can increase efficiency, but that suffers from this phenomenon called rebound, or maybe another name, a Jevons paradox. When we make something more efficient, we tend to use more of it. Actually, a lot of the history of industrial revolution is increases in efficiency. And we have also increased the amount of energy we have used. Also, energy savings suffers from opportunity cost. We cannot turn all the lights off. People will start stumbling and hurting themselves, and it will be even more expensive to build more hospitals to treat them after that, basically. Next slide, please. So this is the last one, the technology neutral solution, or even a solutions neutral. I'm all for political change, social change, everything like that. The thing is, it's way more likely to happen. If we aim for only renewables, it's going to be 3 to 11 times more effort than combined with a technological neutral solution. Thank you.
Thank you very much, Roman. So I will now leave the floor to our last speaker, Stephen. Thank you.
Thank you very much. Delighted to be here. I've been working on climate change for 26 years now. For the first 20 of those years, I was vehemently opposed to nuclear power. I worked for various civil society organisations, including 5 years as director of Greenpeace UK, which of course is anti-nuclear. Then I realised that I was wrong, and as I'm not an elected politician, I was quite happy to say that I had been wrong. And this history gives me, I think, two advantages in perspective. One is that I understand both sides of the argument quite well. And secondly, I know that many people in the green movement, even though I think they are wrong on nuclear and some other issues, they are not bad people. They are not anti-human, they're not anti-progress. So I think dialogue with civil society by the nuclear sector and by pro-nuclear organisations such as the one I'm now running is very important. It is important not to lecture people, but to try and understand different perspectives and put your own point of view. I was very pleased by the title of this seminar that Nuclear for Climate is putting on. By the way, I think it's fantastic that there is a pro-nuclear voice at the climate summit now. That has been missing for far too long. So the event Kirsty mentioned, the Jim Hansen press conference, absolutely fantastic that happened. So well done, Kirsty. Is nuclear energy part of the solution? Answer, yes, it is part of the solution. As other panelists have said, it's not the whole solution. And there is far too much tribalism in the energy and climate debate between different technologies. So the nuclear lobby in the past has been saying too much, this is the solution. And the renewables lobby have been saying this is the solution. Even within the renewables lobby, actually, there is tribalism between pro-wind people, pro-nuclear people, pro-biomass people, if there are any. And that's probably worse in the UK than most other places. We're bad at tribalism in the UK. So nuclear energy is part of the solution. It is not the whole solution. It's an important part for two reasons. One, the fight against climate change, absolutely. Nuclear is very low carbon throughout the life cycle, taking account mining of the uranium, the enrichment, so on, and the decommissioning. The Parliamentary Office of Science and Technology in the UK has produced a very good report on the carbon footprint of different generation technologies, taking account of the full life cycle. And in terms of grams per kilowatt hour, coal is above 800, gas is above 400, nuclear is 11. The only other generation source that is as low in carbon terms as nuclear is large-scale wind. So it is a very low carbon energy source, plus the advantages of reliability and baseload that Kirsty mentioned. Nuclear energy is also part of the solution in the fight against air pollution. And in Europe, we have reasonably clean air, not nearly clean enough. London, where I live, is pretty filthy air most of the time. But we are a lot better off than, for example, Delhi, Beijing, Kolkata, many other Asian cities. And James Hansen has published a paper when he was still at NASA, which estimates that past operations of existing nuclear power stations have avoided 2.74 million deaths from air pollution. He doesn't even, in that paper, take account of climate change. If you avoided climate change as a result from nuclear power, the number of lives saved would be even higher than the 2.74 million, but that's quite high enough as a reason to support more nuclear power stations. I think we need more of the existing nuclear fleet, the generation 3 to use the jargon, and 3+, but I think we also need to innovate in the nuclear sector and to develop the next generation of nuclear power stations, generation 4. And the Weinberg Next Nuclear think tank is promoting both fast reactors and molten salt reactors, which I can say more about in questions if people are interested. But the advantage of these generation 4 reactors, we're also promoting small modular reactors which can be built on a production line effectively and then taken by truck or whatever to where they are to be installed. And that will hopefully, and I'll come back to the issue of cost, but that will hopefully reduce costs in the nuclear sector. And the advantages of advanced nuclear are that they are probably, and I say probably because they haven't yet been built, demonstrated and proven, but they are probably going to be even lower carbon, even safer, and even more proliferation resistant than existing nuclear power stations. And therefore, we need to not only talk about the advantages of existing nuclear technology, which is a kind of historic, defensible, but rather defensive line. We also need to inspire people with a vision. And one of the issues with the 100% renewables scenario is, despite all its drawbacks, despite the fact that it's not actually very desirable for reasons that have been said, it is quite inspirational. And I think those of us who support a broader mix, including renewables but also including nuclear, need to find a way to be inspirational and visionary. Alvin Weinberg, the man after whom my foundation is named, had such a vision, and he was putting it forward in the early 1970s. So well before Jim Hansen came to prominence with his testimony to the Senate in 1988. That's not to take anything away from Hansen, who's absolutely fantastic, but Alvin Weinberg was saying the same thing in the early 1970s, and he said, I'm not against solar utopian dreams, except when they are used as a reason to rule out nuclear. And he was the man who constructed and operated a molten salt reactor in Oak Ridge Laboratory in the States in the late 1960s. And then Richard Nixon shut it down. So Nixon was wrong, as he usually was. I think we need to be able to say, and we can say with confidence, that next generation nuclear power stations are not only possible, but also visionary, and that needs to be our message for the future. Thank you.
Thank you very much, Tom. I'd like to know if one of you already has a question. Otherwise, I would... Yes, Mr. Gentleman.
Thank you. This is very interesting. Peter Joseph from Citizens Climate Lobby. I spent many long years being an anti-nuclear activist after 3 Mile Island, which reawakened latent fears of nuclear war, Hiroshima, the Cuban Missile Crisis. I very much remember the fear that occurred there. And I must say, in a way, you have the same problem that the climate scientists have until recently, which is you have not messaged your message and framed it in a visionary way to the public. And I think if you really want this to happen, you really need to start educating the public and the leaders on what this next generation of nuclear power facilities might look like. Because every time you mention this, people are going to remember Fukushima and the pictures of the hydrogen explosions in those reactors, and they're going to say, no way. No way will you do this near our city, and they're going to want to place it in the desert somewhere. And that's a tragedy, which I think could be helped by better public relations and framing your message, but it's going to be a very steep hill to climb. And the camps have been drawn, it seems to me. There's rigidity in the environmental movement, which I'm embarrassed to say I, like some of you, have been very much a part of. Thank you.
Okay. Does anyone want to talk?
Absolutely agree. Better public relations, better messaging is very important, and that is something that I am trying to do, and Kirsty is certainly doing a lot on as well, much better than me. I think in terms of actually convincing large sections of the public, it's going to be very difficult, probably impossible, until one of these things is actually built and operating. They are paper reactors at the moment. They're very exciting paper reactors for energy policy geeks like me, but they are not going to convince anyone until one is actually operating and shown to be safer and less expensive. I didn't cover the expenses cost, but they are probably going to be less expensive because safety, passive safety where human intervention is not needed, that is designed in rather than being a bolt-on at the end. So yes, I am confident that they will be less expensive, but whenever you say this to an anti-nuclear person, they say too cheap to meter. That worked well, didn't it? So we have to be very careful not to overclaim and overpromise. What we should do is underpromise and then deliver and overdeliver. So yes, better messaging, but progress in reality is more important.
I just want to pick up on that notion of vision and hope. I think that is absolutely right. And you know, my experience all along in environmentalism and everything else is that frightening people, I mean, information is important, but presuming to frighten people is going to deliver a desirable outcome just doesn't work. I mean, when we frighten people, people run, and they run in all sorts of directions. Some of them might run in a useful one. Some, oh, thank you very much. Yeah, some of them might run in a useful one, and most of them won't. Some people hide, some people ignore, deny. If you can create a positive vision, you can get people approximately marching in the same direction. And part of that messaging has to be about this sensible mix of technologies and what it means for the world in a positive light. And we've been having a very long, detailed conversation in South Australia about nuclear this year because we've launched a Royal Commission, which is a very high level of inquiry. And part of what I've brought to that with a senator in South Australia is an extremely positive vision of what this would mean for South Australians. It would mean, you know, what it would mean for jobs, what it would mean for the sort of schools we could run and operate, what it would mean for our science and development industry, all the sorts of things that people can get a handle on. The revenue that it would afford us to enable us to better conserve our parks, to better protect our oceans, etc., actually start to shape a narrative about what the future is going to look like is absolutely essential.
Yeah, I completely agree with that. And so I was growing up at the height of the Cold War, and, you know, I grew up with that fear that you described. And indeed, Ken Caldeira, speaking at the press conference last week, said that he was arrested for protesting against that Shoreham nuclear plant until he changed his mind, having studied climate science. Now, you know, he's obviously an extremely smart guy. But not everybody has the time or the inclination to look at these problems in an extremely rational and scientific way. In fact, most of us, you know, we form our impressions of science, and we have a lot of our opinions come from more of an emotional place. And what I think is really interesting is that research shows that people's preferences for technologies aren't fixed, but the values that those technologies represent are. And actually, what I think we see with the appeal of the 100% renewables vision is less about the feasibility or the practicality of that vision, and more about the fact that it represents a set of values that people want to see in this world related to fairness and being closer to nature and being clean and not being wasteful. And these values are really important. And I think, well, the reason that I began this organization was because I think until now we've only really seen industry and politicians advocating for nuclear, and we haven't really seen a civil society advocacy movement, which we're starting to build this movement, and in doing so we're creating the narratives, we're aligning, we have more in common with our colleagues and our friends in the environmental movement than divide us. We care about nature, we care about wildlife, we care about biodiversity, we care about about the safety and security of our families and people on this planet. And we're prepared to look again at nuclear, which is a kind of a courageous step for many people who, because it takes courage to change your mind.
Thank you. Is there another question? Gentleman here.
Thank you. I'm Hervé de Labatière. I work for the French government. Unless I missed something, none of you mentioned the issue of storage and disposal of nuclear waste. And yet people who argue against nuclear energy usually say that this is an unsolved matter and that in the future it will become either very risky or very expensive or both. What do you answer to that?
I will have a shot at that. Actually, until recently, that has been the case, but here in my home country, Finland, we are right now solving the repository problem, and it's also becoming an export industry for our country. The thing that people often forget or refrain from doing is comparing the risks in a relevant manner. In our book, we went through some studies that were done on the Finnish repository, that what would happen if it leaks, if the study went through several scenarios. And I'm just gonna hit the worst absolute one of them and give you the result. So if everything goes wrong in a time scale that's 10 times faster than it should be able to go wrong, and somebody moved to live above the repository and stayed there for her own whole life, eating just produced food from that spot and drinking water from that spot, then the equivalent radiation dose that the person would get would equal to eating a bunch of bananas in 1 year. And that was the absolute worst. So, okay, could be wrong, but how many orders of magnitude wrong? And still, even eating 100 bunch of bananas in a year is not very dangerous radiation-wise. So we need to compare the risks in a calm and evidence-based manner. And that maybe helps to elude disperse the fear that people have of the waste.
Yeah, as a climatologist, I would like to add something, because I'm always surprised that people that are opposed to nuclear, they want the nuclear energy to prove that the nuclear waste are safe at a time scale of 10,000 or 100,000 years, or even 1 million years. On the other hand, when we look at climate change, we only look at what's going to happen at the end of this century. Because actually, if you look at what's going to happen at 1,000 years from now, it's a catastrophe, because a sea level rise of several meters, this is something that is already written, that will happen. Okay, so just at 1,000 years. So the people ask things on climate that are fully different than what they ask for the nuclear energy.
Just 2 quick points. Thank you for asking about waste. The nuclear industry is obliged by law to look after its waste, unlike the fossil fuel industry, which just bungs it up in the atmosphere in the form of carbon dioxide. And nuclear waste, as has been said, is far less risky than carbon dioxide is. Waste, so-called, spent fuel contains about 80% or 90% of the energy that was in the original uranium. So it is not really waste unless you insist on throwing it away. We should not insist on throwing it away. We should reuse it. And advanced nuclear reactors can reuse the spent fuel. Greens are supposed to be in favour of reuse.
Yeah,
Yes.
I'll just add one more quick comment to that, which is that we, in light of that sort of information, then we need to start demonstrating behaviours that are consistent with that. So if industry continues to demonstrate behaviours that appear inconsistent with saying that it's safe and we can manage it, people are going to believe the behaviours more than the evidence, which is why we're proposing in South Australia to do precisely that and have a rolling storage facility that's approved over relevant timescales for decision makers today. And we're starting at the point we intend to continue at, which is a demonstration that this can be safely handled and safely managed. I think it's very important to remember that people will, by default, they will more likely believe your behaviour than your evidence. And if the two aren't consistent, there's trouble. So there's work to be done there in the way we approach nuclear.
Thank you, Ben. Gentlemen, please introduce yourself.
Yes, my name is Doug White. I'm an activist and journalist from New York City and Massachusetts. And as a 40-year anti-nuclear activist, it took me quite a while to come around to the realization that because we're basically 265 years late in addressing this problem, we are simply not going to make it. We're simply not going to do what needs to be done in time, on a time scale, unless we include nuclear in the mix. And I think it's very important to realize that, sure, wind and solar are going gangbusters. They're going great. And if you add up all of it, it's less than 2% of the world's energy right now. So I think it might be helpful to us to take a look at timescales in terms of the message that we deliver to show, well, if we just stick with conventional renewables, how long is that going to take us if everything works out just the way we want it to? And where's that going to put us in terms of the amount of Celsius increase in temperature? And all of a sudden, the message becomes very clear that you're going to be in the deep shit, big time, okay? And so I think people need to understand on a time scale of what's going to happen to this planet, right? If we don't scale up and include nuclear, it absolutely must be included.
Hi, I'm Stephen Sondheim from the Sierra Club in the United States, and I am anti-nuclear. We have a no-nuclear committee. 3 points real quick. One is, I've asked both anti-nuclear and pro-nuclear people, what's the time scale of bringing on enough nuclear to make a difference on the climate change? And I'm under the understanding it wouldn't do the trick. It would take too long. We have a very intense climate carbon problem right now, so I want you all to speak to that. Second issue is, it's way more expensive. Many of the nuclear plants in the United States are failing and dropping out, asking for government subsidies, huge government subsidies. I'm of the contention that we could do a hard march towards low carbon technologies to make a bigger gap faster than, and using the money that we would be spending on nuclear for these other technologies. And the third is the radiation issue. There are tremendous radiation problems in the United States, and the radiation would have most of its effect in the next 50 to 100 years. It's basically unsolvable. So if you could comment on those points, I'd appreciate it. Thank you.
I'm sure my colleagues have got a lot to add here too, so I'll be really quick. But thank you for your questions. They're really good questions, and urgency is I think something we all agree on. So I guess I have a question about why you would choose to take something off the table. First of all, because given the scale of the challenge that we face, I think we probably all agree that we need to throw everything at this problem. But just to answer your question about rate of deployment, there was a study done this year by Barry Brook and Stefan Kvist, and they looked at real-world examples of energy transitions, and in particular looked at Sweden, which I mentioned earlier has a clean electricity generation mix with a combination of hydro and nuclear, and the rate of deployment for that nuclear was extremely rapid. Per capita, to the extent that they then extrapolated that if we were to deploy nuclear globally at that same rate, or even a bit more slowly to allow for make it a bit more conservative, we could replace all of our fossil fuel infrastructure within 35 years. Now that's a proven pathway in real world proven pathway, and of course France here where we are right now. I'm not hearing much about the success of decarbonisation of electricity here in France at this conference, which is kind of surprising. But maybe that's because of the ideological opposition that we see around nuclear.
Yeah, we've had a few bites at nuclear in Australia over a period of some decades, and probably the last substantial one was in about 2006. And there was one before that in 1997, 1998. And each time this approximate issue of how long it will take to deliver something comes up. It's an argument for starting. It's an argument for hurrying up. If it's going to take time, we have to start. Now, if you go back to 1998 and 2015, Australia's put on a lot of renewables and a lot of fossil energy, and our emissions have gone up hugely. And now we're having the same conversation afresh again, saying we need an outcome here. And it's going to take time? Yeah, it's going to take time. It's going to take time to implement. And in that time, we've got huge headroom to continue adding solar PV on our households and our industry and our commercial premises. We've got huge headroom to continue adding wind into our network, which brings challenges. It doesn't just get thrown up at 1 million miles an hour. These things can, should, must be happening together. And all through that same time as we build out, expand, continue our energy efficiency, we can be preparing a nuclear energy sector. And when a nuclear power plant comes online, it's big. It's a lot of energy. It's a lot of new clean energy. And you don't have to build them one at a time. It's like hanging out the washing. You don't hang out one piece and wait for it to dry and then hang out the next one. You can build a lot. These are solid concrete plans that have demonstrated success in our history with energy. So there's no way that I'm going to have nuclear power generation in Australia next year. I know that's not going to happen. But evidence suggests that using that as an excuse to not get started is an error. It's not a sound pathway to solving this problem.
I'll have a further stab at those. Saying that nuclear is too slow to do it is, of course, correct. It cannot do it alone. That's why we need all the solutions. But it's not a reason to oppose it. It's a reason to hurry it up, as it is a reason to hurry up development of solar panels and wind turbine efficiency and everything. And actually, like Ben said, the actual speed compares pretty well, as you maybe saw in my presentation. The needed decarbonization rates of several % per year has been achieved in Sweden, in France, in Belgium, with nuclear. So if you add to that our current capacity to increase other low-carbon sources as well, and a progressive climate policy, then we could really have a chance. About the expensive, yeah, they are big buildings and they cost a lot. Of course, part of the reason for that is that we haven't been building them, so we lack the experience and know-how. For example, Olkiluoto 3 in Finland, it's a prototype, so surprisingly, it is going to cost a lot. But again, that is not a reason to oppose or ban nuclear. That's, for me, that's a reason to try to make it cheaper. I'm going to leave the radiation for...
Okay, thank you. The timetable issue is absolutely crucial, and the too little, too late argument is often heard from the green NGOs. Ontario in 2003 was getting 25% of its electricity from coal. Then the Ontario government decided to get rid of coal by 2015. They did that at the end of last year, a year early, and they did that by energy efficiency, wind, solar, and nuclear. And the nuclear capacity was significantly expanded in Ontario within 10 years, and as a result, they were the first entity to get rid of coal. I think the issue of cost, yes, nuclear is expensive, yes, it should get cheaper, should in theory, as an objective, get cheaper, needs to be proved, as I said. No low-carbon energy source is cheaper than fossil fuels yet, unabated fossil fuels. I mean, CCS is not is proven, but not proven at small scale. But how long is a piece of string in terms of how much it's going to cost? Shale gas is lower carbon than coal, so it's a step in the right direction, but it's not low carbon enough. So we need to look beyond gas, including shale gas, to genuinely low carbon issues. And on the issue of radiation, I was reading the foreword to your book today by David Mackay, and he said it's like sunlight. If there's too much of it, it's dangerous. If there isn't too much of it, it's not dangerous. Indeed, if there isn't too much of it, it is actually quite helpful because it's widely used in healthcare. So radiation itself should not be a swear word. It's about how much radiation there is. And from nuclear power stations, radiation is very low.
Another question? Yeah.
Hi, David Townsend from Townrock Energy in Scotland. First off, I just want to say thank you, Raoul, for making me really worried about eating this for lunch today. I'm a huge advocate of geothermal energy and also a sort of long-standing environmentalist, and was very against nuclear till quite recently when I started to realize that all of the renewable energy in the world doesn't even come close to stacking up to our energy demand. And then the final tipping point for me was actually, 3 days ago when I saw Raoul get on a bus with an opera singer that he brought with him from the United States and sang about thorium reactors. And I was like, wow, these people care a lot about nuclear energy. There must be something behind that. And then this panel. So thank you very much. It's quite enlightening. My question is around actually it's kind of two questions that are very, very overlapping. But one hand, what do you think of Bill Gates's TerraPower technology, which aims to use nuclear waste to produce more energy? And do you think that the Bill Gates Mission Innovation Fund, now that's been announced a couple of days ago, could be used to rapidly evolve nuclear into the next stage?
Can I just quickly jump in? Brilliant. Thank you so much. Wow, that just made me feel really warm inside. Thank you. We're going to tell Eric, the opera singer, that story. So, Bill Gates' TerraPower. The thing that I'm really excited about with regards to that reactor design, which, by the way, I don't think is going to work, is the idea that he started out with a design specification which was about designing a technology that can solve problems in the world that he was caring about, such as solving poverty. And I think that is the promise of the next generation of nuclear, because we can scale up the current technology in countries that have strong regulatory capability and a grid and skills and supply chain. But what we can't do is really scale that up into the world that into other parts of the world that don't have all of those assets. So we do need new technology that is proliferation resistant. That's very, very simple, that's simple and safe, inherently safe, that can be mass produced, and can genuinely compete with coal. And that's what Bill Gates is trying to do. And by the way, about 50 other incredible entrepreneurs just in the United States alone. But there is nuclear innovation happening all over the world, a lot of brilliant young engineers being attracted into the nuclear industry because they're environmentalists. So
we've had a lot of discussions internally in the course of this week about technology and geothermal technology, for example, can be outstanding. And when the resource is good, use it. We've really tried to develop hot, dry rock, deep geothermal in Australia, and it's proven to be incredibly difficult. And that was a bit of a movement for me sort of back in 06, 07. Had great hopes for that in Australia, and seeing that not happen was really challenging. Right. I mean, you know, it's as expensive to drill oil or gas, but your product is heat, which isn't as valuable as oil or gas. In terms of the reactor technologies, I mean, you've mentioned TerraPower specifically. I see a spread of really exciting technology coming on, and a discussion that we had earlier in the week is that I think that there's probably a little bit of distinction. I think there's a family of technology companies that we're really more talking now about a deployment agenda rather than a research and development agenda. Now, there's both. But I'm particularly excited that I see some that really have a deployment agenda. I've been working really closely with General Electric Hitachi and their PRISM reactor in terms of a project in Australia. And yesterday, a company called Terrestrial Energy that I'm involved with announced that they were adding to their board Caterpillar Inc. Now that's a company that does its homework, that does its due diligence. They build and operate hugely expensive equipment in really high-risk industries. I think that's an enormously positive sign that there are some of the small modular reactors, some of the molten salt reactor designs, where the question is not one of fundamental scientific research, it's about implementation pathways, and it may be something that's nearer term than we think. That's a hugely positive sign. And on the same token, a question I asked Stephen yesterday, which is, you know, if China announced it was going to cookie cutter out 200, 500, 1 gigawatt light water reactors, would that be a good thing? Yeah, it would be a good thing. Because just as you've hit on, the sheer quantity of energy... Yes, oh yes, indeed. Indeed, that was Stephen's answer I gave. The sheer quantity of energy we're talking about is enormous. And there's going to need to be a transition period of technologies toward what I think will be optimal solutions. The urgency right now is eating away at that bit of the pie that's called coal.
Yeah, I think there are lots of exciting technologies out there, and we shouldn't pick winners. The British government and the French government haven't got a great track record in picking winners. So let's go for all of them, at least at prototype stage, at least for the moment. I mean, you may be right that TerraPower is not going to work. You may be wrong.
we don't know.
We don't know.
But we've got to try.
So we've got to try. So, and in terms of the prototypes that we're talking about in the UK, what we need from the government is £10 million per prototype, which in government spending terms and in nuclear economics terms is pretty small beer. So let's do it. Let's just build some prototypes and see which ones work.
Yeah.
There's a gentleman in the back, yes. Can you introduce yourself?
Yes, thank you. I'm Janne, and from Finland. I'm actually the co-author of this book discussed here. And I'd just like to continue a little bit on the discussion about radiation, because I come from a country where natural radiation background radiation rates are fairly high. I was born in a city where there are spots, even now, that have higher radiation doses than what you would get most probably in most areas that are now excluded outside Chernobyl. And the thing that we have been talking about these things with people who oppose nuclear power for the longest time. And one thing that's always absent from their discussions is even though that we hear that radiation is dangerous, we almost never hear how dangerous it is. Like, okay, well, it is possible that there are in the United States that there are high radiation levels, but how high, and what are the actual dangers they pose? We would very much like to have answers to these questions so that we could compare the risks of different options, because we know that the alternatives to nuclear are not without risks either. And just one more thing, we brought enough free books here for everybody, so before you leave, just pick one up. Thank you.
Thank you. Another question? Yeah.
Hi, I'm Paul Jenkins from London and a member of the Green Party in the UK, where I'm pro-nuclear. I'm debating this issue a lot with fellow Greens, quite a few of whom are quite favourable to this, to at least some nuclear. The difficulty I have, I think, is most people are not energy geeks. As Ben mentioned, renewables is like a brand, and it's a very powerful brand. The anti-nuclear people have, the nuclear power, no thanks, a very iconic symbol. The debate reminds me a bit of the debate over climate change with climate change deniers. There were some very useful resources, such as the Skeptical Science website, where you could refer people to, look, here are the answers, because this argument just shifts around so much. There's so many different objections to it. So I don't know. Does the pro-nuclear movement need to get into having a brand, having a logo, having a kind of a single website where you could direct people to, look, here are the answers? Because I don't know. I've read Climate Gamble. There's some very useful resources out there, but it seems a bit disconnected to me. It would be good to have something overarching.
I'd love to make a comment on that. The first thing I'd like to say in response to that is to heap a little bit of praise to the woman at the end of this table who, a remarkably short amount of time ago, proposed this concept of nuclear for climate. And it was at a conference of Young Generation Nuclear where I attended, and it was probably one of my first experiences of being a little bit embedded in a nuclear industry conference. And I found a lot of people that looked extremely demoralised about the industry that they worked in. And I found a culture where it's an obsessive focus on safety to the point where people become convinced that they're the most dangerous energy source. Whereas here I am, the outsider, understanding just how comparatively amazing their product is. And it was like it's an industry that's forgotten to sell its product. And no other industry acts that way. There are warm and cosy natural gas advertisements on Australian TV all year long encouraging me to buy their product. Airlines, show you pictures of people on beaches. They don't tell you they're safe. And, what Valerie's done with Nuclear for Climate is, I think, tap into something that was badly needed, which is giving this amazing group of young professionals a banner under which to be really proud of what they do. And I think that's been incredibly powerful in a really short amount of time. And I've seen, and directly asked the question to check, and I've had people tell me how welcome this is for them. So I think building out on that along the directions you've talked about is really, really important. It's challenging because part of the anti-nuclear narrative is the big bad nuclear industry. However, in my experience in advocacy and outreach, actually standing up for yourself and being proud of what you do tends to work quite well. And that can be achieved without making it something that makes people feel not so great about it. The technical questions are largely answered. The Nuclear for Climate booth's got answers to those technical questions. I think this is a huge communications challenge. It's a huge community building challenge to give, and the experience again I've had in Australia, it's about giving politicians permission to come out and play on an issue. You know, there was so much fear about any politician speaking out because of what they thought would happen, and as soon as a safe space is created, amazing change can happen. And part of that communications branding process is about creating enough safe space for conversation. So, yeah, you know, I'm waffling on a little bit now, but I think you're hitting exactly the right lines. There needs to be a lot more effort around that, and I'd encourage it to be an industry that reacquaints itself with its own product and the amazing product it can deliver, and just how important it's going to be for this century. It's an incredibly powerful platform that has been neglected for too long.
Thank you.
Hi,
Another question?
Mirto Tripathi. I'm actually working for the French nuclear industry, and I would like to thank you warmly for the comment you just made. My question was kind of exactly this one, which is I have been listening to James Hansen last week while he was there, and I followed some of you during your last interventions. And you always use France as an example, as proof that nuclear energy works, that it's safe, economical, geopolitically precious because it provides energy independence, and the most importantly, it is safe and clean. Now, my question to you all is, what is your perception of why French people seem to be so shy about this wonderful example they are? Why are they so ashamed of it? And how can they, but as a public, not especially as the industry, as the general public and citizen, overcome that shame?
Well, I would like to answer not so much as a climatologist, but as a French person. So I know how it works. And I think that the main reason is a number of lies from the anti-nuclear movement, and that put the fear in the population. And I give always this example that, you know, when there was the Chernobyl accident, there was the cloud of radioactive material that went over most of Europe, and including France. And the anti-nuclear movement have been saying, oh, the government lied to you. It says that the radioactive cloud stopped at the borders of France. And in France now, today, everybody is convinced that indeed the French government lied at that time, because it has been said so many times. So it became a truth. Was in fact, the government said indeed that there was no risk for health, but in fact that indeed the cloud was over France, that an increase of radioactivity was observed over France. So, and I could give other examples like that in my opinion, why our French people feel that nuclear industry is bad, it's because of lies from the anti-nuclear movement that have been extremely successful. And it's very difficult to fight against a lie, because, you know, you can say something in 10 seconds. I mean, someone can tell you in 10 seconds that, for instance, there is no solution for nuclear waste. And then you have 10 minutes to explain why it's not true. And actually, I made a lot of debates against, climate denial. It was the same issue, the same problem, that, you know, climate denial can tell you something which is wrong in 10 seconds, and you need 10 minutes to explain why it is wrong.
I'm pleased to be able to say that I'm not guilty of having ever said that lie in my past career. I didn't even use the health and radiation and accident issue particularly. What I did use quite strongly, and what I still believe, is that proliferation is a serious risk. It's not as serious as climate change, granted, but it is a serious risk. And I think, to answer your question, to try and answer your question, I think the link with nuclear weapons is a major problem for making nuclear cool and making people being prepared to say they support nuclear. I personally support nuclear power. I do not support nuclear weapons. I think that all the countries that promised in the early 1970s and the Nuclear Non-Proliferation Treaty to negotiate away their nuclear arsenals, which includes your country and my country, should do so. They should do what they promised to do 40 years ago, 45 years ago, whatever it is. And remembering my Greenpeace days again, Greenpeace was founded to campaign against nuclear weapons tests. The French government then sank the Rainbow Warrior and murdered one of our staff members, or in the past. So that is quite a difficult thing to overcome. So I think what the French government needs to do and what the British government needs to do is to give up the fantasy that having nuclear weapons makes you a world power and actually grow up.
Okay.
Bravo. It would certainly make our life a lot easier if there was a lot more effort in that direction, wouldn't it? A very quick observation is that I think that in countries where you have extremely high rates of vaccination, after a generation or two, you can start to see rates of vaccination fall off after people have lived with something for a little while and they've forgotten the good it was doing in the first place. And I think there may be some of that phenomenon here. You know, having looked at what it would take to run a decarbonised electricity system essentially without using fuel, you know, essentially foregoing the concept of fuel and trying to operate a modern economy. That's so hard, but that's not understood. You know, people don't even understand how the existing system works, let alone appreciate the fact that they've had it zero carbon for a really, really long time. So it becomes quite easy to say, I don't want that anymore. I don't want that anymore. Same as vaccinations, because everyone's been healthy for a generation. We've forgotten what measles is like. We've forgotten what whooping cough is like. That's a problem. And again, I feel I've spent a lot of time criticising the anti-nuclear movement, and I'll do that where I feel it's appropriate, but I also prefer to put focus back on where we have agency. And part of overcoming that is actually, again, continuing to sell your product. Continue to actually explain to people what you've got and why it's good and why it's important. Nearly every other industry does that on a continual basis. It's part of doing business. And if an industry allows people to forget its value, there will be consequences. That's part of the consequence, I think.
Okay. I think there's a lady who wanted to ask a question for her.
Hello. Hi. I'm thinking from the beginning of the presentation in Ben heard, Mr. Ben.
Could you introduce yourself?
Yes, my name is Sylvia, and I don't know if I'm pro-nuclear or anti-nuclear yet, as everyone is saying, so... I'm thinking about renewables. You say not always are low impact or like sustainable, etc. At the end, if they are ethical or not. I'm wondering about nuclear energy, if there is such a ethical consideration, because we are mostly speaking about if it's safe or not, or if it's cheap or not, if we have time to, low carbon, etc. What about ethical issues? To mention some of them about the mining, especially in countries that where we get the fuel and maybe they are not as considered as we want to call ourselves so ethical. Yeah. So are you or any of you aware of those like unethical practices related to nuclear energy?
Yeah, absolutely.
Which of them, and what is the industry doing for that? Not only like making it cheaper and low carbon is enough for me. So that's
I mean, my country doesn't use nuclear power, but we mine and export uranium to the rest of the world, so which puts us in a position of remarkable hypocrisy for one thing. So we have exposure to that end of the fuel cycle, the mining of the material. And as you would expect, it sometimes comes into conflict with Indigenous Australians, which is not a uniform voice. You know, like in most countries with a history of Indigenous occupation, it is quite a complex, multifaceted issue. So it comes up. Just about everything I feel that has an ethical dimension for nuclear is something that is more or less faced across the board for anyone who's in extractive industries of any kind, anyone who's in industrial scale energy of any kind. There are some fairly common threads. So I think it's very important to take a moment to question whether what we're arguing about is social justice imperatives, which should be universal, versus something that's actually a specific issue relating to nuclear energy. BHP's dam collapsed and they were mining iron ore and they killed 20 people, destroyed a village, destroyed a river. Extractive industries carry risks, and they certainly are not unique to the uranium industry, nor is the uranium industry's risks particularly better or worse than any other extractive industry. I happen to argue that it's a great deal better because the sheer quantity of energy that we get per unit of material we have to move from the earth is enormous, and compared to the land disturbance of a coal mining area or a large-scale biomass program, I think you actually come out with quite a very, very good outcome. So from a technical perspective, these things for the uranium industry need to be normalised back to how much energy. So what impact am I having per unit energy? Otherwise, you can't actually get a clear picture on it. Now, the only thing I think is particularly unique to nuclear is that having been an industry that has had enforced upon them that they take responsibility for their waste, there are long-term timeframes there, which is sort of ironic and a good thing that we have to take responsibility. And at which point I would invoke Stuart Brand, who taught me something in his book, Whole Earth Discipline, about the notion of 7 generations, which is a sort of a North American folklore saying, I understand, that we have a responsibility to 7 generations into the future. And I think it's commonly misunderstood and misquoted, and what Brand is saying is that we have an obligation to 7 generations in the future and no more, because to do so is to prejudge the capabilities and the needs of people too far in the future, and we don't know. But if we can feel that we take responsibility for 7 generations, we're taking responsibility for the 100 years that François Méry is talking about. And then we can come up with a decision that's actually sensible on the timeframes that we can work in. So my general experience with the nuclear industry is that it has the same ethical obligations as any extractive industry and any industrial scale energy production industry, with a slightly unique twist in the used fuel, which we need to do right.
Thank you. I think we're finishing our session, but you have one short comment.
I will continue shortly. About the ethical questions, as with everything else, we really need to do the comparison. All the energy sources we use have ethical consequences, so we need to compare. Also, we need to compare the use of energy with the fact that we don't use it, which means for many poverty. Poverty kills much more people in the world every year than any energy source does, or energy use. To come to, for example, the waste situation, is often said that we need to look after the waste for hundreds of thousands of years. But if we fail in this climate fight because we didn't use nuclear power, we were afraid of the future generations maybe getting radiated a bit by it, I think that they will be asking that how dangerous this nuclear waste actually was compared to the climate catastrophe that they may be experiencing.
That's a great conclusion. Thank you very much, Riley. And I want to thank all our speakers. And also invite you to come to visit our website, which is nuclearforclimate.org, see what we publish on speakers. We actually have 2 booths here. We're in the blue zone, but we also have a booth in the Gallery of Solutions, where you will be able to meet all our experts until tonight. Thank you very much for your attention.